Hi guys, I'm Isabel.
And I'm Larissa.
And today we'll be talking about
exploring the connection between chemical reactions and food preparation, such as how heat-induced reactions affect the taste, texture, and safety of various dishes.
like how does this, with just a little heat,
Turn into this.
For our examples today, we will be showing the chemical reactions with an egg.
Isabel, why when frying an egg is there a chemical bond?
When the heat is applied to the egg, the water evaporates, causing the proteins in the egg to unravel and form new chemical bonds with other proteins.
Wow, that's pretty interesting.
But Larissa, do you know what it means for an egg to go through denaturation?
Yes, in the original structure of an egg, there are chemical bonds that hold the liquid substance together and break apart when in contact with heat. Evaporation of the energized liquid molecules lead the proteins to undergo denaturation, the process of proteins unraveling and rearranging the structure of an egg.
That's so cool. Did you also know that an egg goes through a chemical reaction?
Yes, so when cooking an egg, the reactant is the raw egg and the product is the fried egg. The heat from the stove initiates the chemical reaction which causes the protein to unravel, changing the composition and appearance of the egg.
That's interesting, but did you also know that the state of matter changes when the egg is cooked?
What? How does that happen?
When the egg reaches a boiling point, the liquid goes through a process known as evaporation. The liquid turns into a gas and leaves a substance, leaving behind a solid. To make up for the evaporated substances, the bonds holding the proteins together weaken, causing the protein to unfold and expand.
Hey, that reminds me, did you know that even when the state of matter changes, no mass is gained or lost in the process?
Seriously? Even though it becomes a new substance?
Well, it actually doesn't become a new substance. Since this is a chemical reaction, matter cannot be created or destroyed, meaning the egg is still an egg before and after. Mass is not lost in this process, and the water evaporates out of the egg, and the rest of the liquid ends up bonding and solidifying with the proteins.
Thanks for clarifying that. By the way, eggs also undergo a process called coagulation.
What's that?
When making eggs, the water evaporates, leaving the proteins to thicken or coagulate. This also changes the internal molecular structure of the egg, another reason for its change in state of matter.
Thanks for explaining. Do you know what else is kind of strange?
What?
The fact that all this can only happen when the egg reaches its boiling point.
So you mean that there's a minimum temperature that must be applied in order for the eggs to fry?
Exactly. Once the egg reaches its boiling point, the molecules move so fast they turn into gas. These form bubbles which rise to the top of the substance and eventually burst and release gas as shown here.
Got it. Won't cooking it at its boiling point also kill any risk of getting salmonella, making it safe to eat?
Right. Speaking of cooked eggs, should we try this?
Yeah.
Wow, I can't believe that this turned into this by just adding heat.
Right? It has a completely different look, taste, and texture.